Welcome to another one of our introductory videos relating to temperature metrology. In this session we'll be discussing thermocouples and their correct use for measuring temperature. Firstly, a word about the difference between a PRT and a thermocouple. A PRT, platinum resistance thermometer, has its sensing element at the end of the probe. For the more accurate PRTs, this will be a coil of platinum wire, which will exhibit a change in resistance with a change in temperature, and we can determine the temperature by measuring this resistance. A thermocouple is a different entity altogether. It comprises of two dissimilar metals joined at one end, and there's nothing special about this end, and instead we rely on the Seebeck effect. This effect being where there's a temperature gradient across the length of the wires, there will be a voltage produced which is proportional to the difference in the temperatures of both ends. It follows then that to measure something hot, we need to know the temperature of the cold end, and this is where things get a little more complex. Here we have our thermocouple sat at 100 degrees C, plugged into a precision thermometer such as the milli-K. Behind the connector here is a temperature sensor which is measuring the temperature of the cold end, and you can see that we can read 100 degrees C on the display. If we don't have a precision thermometer and we want to use a digital voltmeter to measure the voltage directly, then we find that when we measure this voltage, it will correspond to a temperature using lookup tables of the hot end minus the ambient temperature, and this is because we haven't taken into account the temperature of this cold junction. In order for us to measure the temperature directly using a DVM, we need to create our own cold junction. So here we have our reference junction made up of the matching thermocouple wire sat in an ice bath at 0 degrees C. If we now connect this to our DVM, we can see that it now reads the correct temperature close to 100 degrees C. Now this method is simple, it's low cost and accurate, but you do need to keep replenishing the ice. A more convenient solution will be to use a dedicated thermocouple reference unit, such as our Model 937. This uses solid state technology to sit at 0 degrees C 24 hours a day, 7 days a week, and requires no maintenance. We also have high capacity solutions which can reference hundreds of thermocouples, and we'll include a link to these in the description below. Thank you for watching. Be sure to click on the link below to subscribe for future videos.